Okay, the next part over unit 4. Ha ha ha. That is not big enough. There you go. All right. So over unit 4, this is your electromagnetic spectrum and your couple calculations that you did there. Okay. So electromagnetic spectrum, we had the little saying. Remember, rabbits mate in very unusual exotic gardens. They all stand for radio, micro, infra, visible. So remember, visible goes to Roy G. Biv. Okay, your colors in that order. Okay, the order does matter. And then UV, X-ray, and gamma ray. Okay, so not necessarily memorizing the spectrum is important, but memorizing the order is important because it tells you about your frequency, energy, and wavelength. And that was the big thing here. This is when you guys did your flame test lab. And you guys had to analyze your colors and figure out which one was high energy, low energy, and you kind of did some stuff with that. So just know that the gamma ray, we think about the Hulk, so lots of energy. Radio waves are floating around us right now, low energy. Frequency and energy are directly related, so that means they're the same, okay? And then wavelength will always be opposite, okay? Oops. Be opposite. So some of you guys like used to go with your finger in the air and go like high frequency, little itty bitty wavelengths, and low frequency and huge wavelengths. Okay, so if it helps you remember that, that's cool. So that's all you need for that part. The couple calculations that you guys were asked to do in this part of the unit was the C equals lambda frequency, and then you had the E equals H times frequency, okay? The C stood for your speed of light. So remember that was 3 times 10 to the 8th power, but we don't type it in the calculator like that. This is where you go 3E8. So don't forget using that shortcut so you don't make little silly mistakes on your calculation. So it would be this button on your calculator. The X to -1, and there's 2 little E's on top of it, okay? This is just your wavelength, okay? And that's going to be measured in, sorry, that's written very messy, but it's written in meters, and this will be frequency, and that's usually in hertz or per second. Over here on this equation, the E is energy in joules, okay? The H is Planck's constant, and by no means do you have to memorize these. These are all in your formula chart, okay? So that's why I'm not going to spend too much time on this. 6.63 times 10 to the -34. So once again, when you go to type it in, you would do 6.63 E -34. And then once again, this is frequency. Yeah, and if you need help with any calculator things on the day of the test, just let me know, okay? Okay, so you guys have a couple calculations that you can do there. If you happen to need the way the triangle is set up, okay, just know that the C goes on top, and then you put the other 2 down here. Same thing with this guy. You put the E on top, and then you put your H in that one right there. You might have a 2-step question, but know that in your formula chart, you actually have it all combined together, so you don't have to even guess on that one. You don't have to try to figure it out, okay? Just plug and chug and put them in the right spots, okay? So that's it for, this was Unit 4. Unit 5 had to do with electron configuration. So let me see if I can move that up here. Okay, so for electron configuration, okay, we're going to use the example of sulfur. So hopefully you have a periodic table near you, okay, and you can kind of follow along on your periodic table. If you, this is Unit 5, technically. Okay. So you have your little periodic table that's totally backwards. Sorry. Okay, like that. And so remember, when you're doing electron configuration, you find who you're looking for. So sulfur is like right about there, okay? And then you follow along with your finger and you go through the different parts of the periodic table. Remember, this first section, the first two columns, this is the S block. Yep. And so S block can have 2 electrons, 1 orbital. So if you remember back to the analogy of the bunk beds, okay? The middle, the transition metals, this is D. This one can have 10 electrons, 5 orbitals. And this area over here is P, and that one can have 6 electrons with 3 orbitals. Okay, so when we go to find sulfur, we're going to follow along and we're going to use those letters as well as what energy level we are on, okay? One last thing that I just want to kind of remind you is that when you get to the D block, you start on 3. You go back in energy level, okay? All right, so when we're looking at sulfur, we're going to follow along. You go 1s2, so we're done with the first row. Now we're 2s2. We go across 2p6. Next level, 3s2, and then you should be going 3p4.
Wait, is that a D in the green?
Yes, yes. Sorry. Okay, so this is the electron configuration. Your noble gas notation, you're going to go up a row over to your noble gas. So the noble gas that is up a row from sulfur is neon. So I would put neon in the brackets. Okay. And then I would go continue on from there. 3s2, 3p4. And that's it.
I like that one better.
Mm-hmm. That one's nice. So I think that's all you really have to know for this. Any questions?
What's the E stand for? Just go up a little bit. Is that energy?
Yes, energy in joules. Okay, so just put Unit 6. Let me at least give you the trends, and then I will let you guys kind of look at some questions. Okay? Okay. Our last little bit that I want you guys to have, just draw yourself one big rectangle. This represents your periodic table. Put a big B, little s, huge heart, little heart. Okay? So what this is telling you is this is a summary of all your trends. Okay? And what is the argument whenever you're going down a group?
The thing gets the electron, like shielding, gets bigger.
Shielding. Good.
There's more layers.
Yep, more layers. And then when you go across, you're increasing your number of protons. So that is Zeph, or the effective nuclear charge. Okay?
What's the R stand for?
I'm going to tell you that in just a second. Okay? So those are your two arguments. And you can kind of use that to kind of picture why the trends are there. Okay? The B and the little s are for radius. Whether you're talking about atomic radius, ionic radius, it follows the same general trend. Okay? There's a little piece about ionic stuff that we did learn about, but you don't have to worry about it too much right now. The big heart versus the little heart, okay? I put those backwards, sorry. That has to do with electronegativity. And ionization energy. So remember when we learned about bonding, electronegativity played a key role. That was kind of like in a game of tug of war is the winner. Is the one that's pulling the hardest. Okay? So he has a bigger attraction for the electrons. Ionization energy is how much energy does it take to take an electron away. Okay? So the stuff with the big heart, really, 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 really hard to take something away from that. The little heart, super, super easy. So we're talking about like francium versus fluorine, okay? And you just follow your trend across like that. The last thing from Unit 6 that you needed to know was your cation radius difference and your anion radius difference. And the inappropriate but easy way to remember it is that if you gobble up an electron, you get fatter, and if you throw up the electron, you get littler, okay? So that's the way to think of it. But what it happens is, so we have magnesium, let's go back to our example, magnesium versus magnesium 2+, okay? He lost electrons, that's what the 2+ means. So therefore, this is big, this is small. For anion, we can do somebody like oxygen versus oxygen 2-. He gobbled up 2 electrons, so he got bigger. So this is the small one, and this is the big one. The reason this happens is repulsion. If you add more electrons in an already electron-dense area, they're all going to repel each other and poof out. Okay? Over here, you increase that effective nuclear charge. They zoom in. It's holding on a lot tighter. Okay? So that's it for Unit 6.